Welcome back. Let's continue proving our theorems. In this lesson, we're going to prove the theorem which says that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. I'm going to show you this. Let's just go through some of the theorems that we need to prove. Remember, you can pause the video here and check the theorems. Make sure that you know how to prove all these theorems because one of them is going to be in the exam. Right, now this is what we want to do. We want to prove the theorem which says that the angle between the tangent to a circle and the chord, right? What we have the tangent here. This is the tangent, and then we have the chord. Okay, right. We can also talk of the tangent and chord PR, but I'll just do with the chord QR. Okay, right, and then this angle between the tangent and the chord, which is this angle here, all right, this is the angle between the tangent and the chord. What does it say? Is equal to the angle in the alternate segment. Right, if you check this chord QR subtends what? Subtends angle P, where in the alternate segment, in the other segment, right? Because a chord divides a circle into two segments. We have this segment, we have this segment also this side. So we're saying this angle P is formed by chord QR, is subtended by chord QR in the alternate segment, and then this angle P is equal to this angle. That's what it says. The angle between the tangent to the circle and the chord drawn from the point of contact is equal to the angle in the alternate segment, right? So we're given this circle with center O, and then SRT is the tangent. SRT is the tangent at R, at this point R. This is the point of contact, right? QR is the chord. We want to prove that angle QRS, which is this, is equal to angle QPR, which is this. Okay, so now remember, we have to do our constructions, right? So which construction do? We draw, or we construct diameter from the point of contact there, passes through the center, and then let's say to point, let's call this point U maybe. Okay, and then after that you join U and P like that. Okay, right. Why do we do that? Right, why do we do that? If you check here, we have formed an angle subtended by the diameter, angle in the semicircle, right, which is this. Okay, let's just discuss first, right? And also remember, this angle is 90 degrees. The angle between the tangent and the radius, or the angle between the tangent and the diameter, is 90 degrees. And then by constructing this RU, we have created angles in the same segment. Okay, check this bow tie, right? You see that? So we have created angles in the same segment, meaning that this angle is equal to this angle. They are subtended by arc QU there. They are angles in the same segment. Okay, right. So remember that. What construction do? We construct diameter to a point on the circumference of the circle, and then after that we join that point to the point where our angle we are proving is. Okay, so like here our angle is at P, so we join U and P like that. Okay, in the theorems we're going to use, we have an angle subtended by the diameter, or angle in the semicircle, right? We also have angles subtended by the same chord. We can say angles in the same segment, and also an angle between the tangent and the radius. So these are the theorems we're going to use. So now I want us to write our work neatly. Right, construct RU, and then join U and P like that. Okay, so we have formed our angles. The angles that we want to prove here is angle QRS, R1. Right, let's name this one P1. Let's name this one P1. Okay, and then we have this angle that we have formed here, which is R2, and then P2. Okay, so we want to prove that R1 is equal to P1. We want to prove that this angle is equal to this angle. So we say this angle is 90 degrees because of tangent being perpendicular to radius. So we can say angle R1 plus angle R2 is equal to 90 degrees because of tangent perpendicular to radius, right? And then we have this angle also, which is 90 degrees. So we can say angle P1 plus angle P2 is equal to 90 degrees, and then reason angle in semicircle, right? And then, but if you check, but angle R2, this angle and this angle are what? Are equal. But angle R2 is equal to angle P2. Then what's the reason? Angles in the same segment. Angles in the same segment, right? So now if angle R2 is equal to angle P2, so it means these two are equal, right? And then we're saying angle R1 plus angle R2 is equal to 90 degrees. Angle P1 plus angle P2 is equal to 90 degrees. So it means that if these two are equal, therefore angle R1 is equal to angle P1. Okay, done. That's it. That's it. So you can say therefore angle QRS is equal to angle QPR, like that.